Hi, my name is Johanna Hagen, and I'm going to talk to you about the transesterification, which is producing biodiesel. Just an introduction, biofuels are either a liquid or a gas, which are produced from sources that can be replenished rapidly, such as plants, agricultural crops, and municipal waste. Current biofuels are produced from sugar and starch, such as wheat and sugarcane, which are all part of the food chain. One of the targets for energy researchers is to find a sustainable route for biofuels from non-edible plants and biomasses, such as agricultural waste, forestry residues, or purpose-grown energy grasses. These are examples of so-called advanced biofuels. Current biofuels, such as ethanol, have lower energy content compared with conventional hydrocarbon fuels such as petroleum and natural gas. The aim is to produce fuels that have high energy carbon content and therefore have higher volumetric energy density. This can be achieved by chemical reactions that remove oxygen atoms from biofuel chemical compounds. These compounds include fats and oils, most commonly vegetable oil. This oil is cut down through a process called transesterification. We do this because vegetable oil at low temperatures begins to gel, and this is an issue with combustion. Vegetable oil is a glycerol and 3 fatty acid chains. Methanol is turned into a methoxide using a base. The methoxide ion attacks the carbonyl carbon on the fatty acid chain, which leads to the separation of the fatty acid from the glycerol. My colleague, Dalton Zanetti, will go over the mechanism.
Hey, I'm Dalton Zanetti. I will explain to you the process in which biodiesel is made, and we first need a methoxide ion. So we have to start with a methanol. So we have our CH3 attached to an OH, and this has to occur in a base, so say NaOH. We have the OH minus right there, the lone pair. We'll take this H, and these electrons will go back to the O, which would create CH3 and O minus. So this is the methoxide ions that is going to break our ester chain. Alright, so now we have our methoxide. Now we need to take triglyceride, which is the ingredient in vegetable oil that's being reacted here, which looks like this. It's a big mess. C H H C H C H H O O O C O C O C O, and it just has a long chain. This depends on which vegetable or which kind of oils or fatty acids that you're using. So this side of it is the glycerol side, and this is our fatty acid chain that we're using in here. So we just have a long chain for all of these. Now this is where our methoxide comes in. So we have our CH3O minus right here. So one of these lone pairs wants to attack this carbon because we have a partial positive here and a partial negative here. So when this attacks here, these are going to roll up here, and then eventually these electrons are going to roll back down to create the double bond and going to break this bond, thus breaking the ester here. And this is going to happen for each one. CH3O minus, attack there, come up here, go roll back down, and that's going to break. CH3O minus, attack here, roll up, roll back down, and that's going to break. Alright, so after the methoxide comes and breaks the chain between the O and the carbonyl carbon, those electrons from the O and the carbonyl carbon are going to roll back to this O. So we're going to get a minus on every single one of these. Now, from making methoxide, you're going to have water as a byproduct, and you don't want water in the biodiesel solution because then it won't process it completely. It's insoluble in it. So all the water molecules that we have left, HOH, these are going to take one of these, the hydrogen, and these electrons are going to roll back to the oxygen for each one of these, which would create our glycerol group. These are the H's that are being added, which gets rid of our water molecules so the reaction can be processed. Now, okay, so we have our glycerol group here. Now the other half, which is the actual biodiesel part, was those long chains that the methoxide attacked. So it's going to create a methyl ester. So we have OCH3. Here's our C, double bond O, with a long chain, which also, it depends on what fatty acid you're using. And we get 3 of these for each one. So these are going to be our biodiesel, which then can be burned and used as fuel. And this is a byproduct of the whole reaction. This is actually denser than what these are going to be as well. So the layers are going to separate. So the top layer, you're going to see your methyl ester, and the bottom layer, you're going to see your glycerol. And our NaOH that we started out with is going to become NaOH again, which acts as a catalyst throughout the whole reaction. And that is the transesterification process, which leads to biodiesel.